Hey everybody, Mr. Covey here, and this is a real quick recap of solving linear trig equations, okay? So if you missed class or you just wanted to kind of like hear the ideas again, it's going to be a real quick video about that. First, you have to know everything from Unit 2. You have to know the coordinates. You have to know when certain trig functions are positive or negative. You got to be able to evaluate stuff in the unit circle. So take a second now, fill this out. If you can't fill this out easily, re-memorize this information. Extremely important. Okay, so there are your coordinates. Remember, we got quadrants 1, 2, 3, and 4. Sine is your y coordinate, cosine is your x coordinate. So if you look somewhere like quadrant 2, your cosine, which is your x coordinate, is negative. Your sine, which is your y coordinate, is positive. Tangent is y over x, so it would be a positive over a negative, so your tangent would be negative. Cosecant is the reciprocal of sine, so it would still be positive. Secant is the reciprocal of cosine, so since cosine is negative, secant would be negative. Since tangent's negative, cotangent would be negative as well. If that's not like something that you were able to easily, you need to go back and review, do some unit circle practice. Okay? Because we're solving equations based on this knowledge, okay? And these are actually questions right here that we asked you in Unit 2. You guys did a really good job with these. And they're saying find all angles between 0 and 2 pi. Remember, that's what that means. Including 0, not including 2 pi for each equation. So I'll do one of these, two of these, and then I'll let you guys do a few of them. First one says the sine of my angle equals root 3 over 2. What's my angle? How you do this is up to you. What you should be thinking about is what angles are going to have a positive sine value. Okay, well, there's two quadrants with positive sine, first quadrant and second quadrant. So I'm going to be looking for two angles, one in the first quadrant, one in the second quadrant, whose sine is root 3 over 2. That means their y coordinate is root 3 over 2. Look at the picture above, or kind of just thinking about it, if you have it memorized well. Pi thirds has a sine of root 2 over 2, or root 3 over 2, and so does 2 pi thirds. Okay? So if you think about this as being an equation, we didn't really do any algebra, but we were able to determine that these were the two solutions to that equation just based on what we know about trig. Okay. Go ahead and solve the rest of these real quick. Again, this is good unit circle practice. Okay, there's the answers to all those. Again, we're just reversing evaluating something on the unit circle. The idea here is if you know what the cosine of 11 pi 6 is, if you're able to say that that is root 3 over 2, then you should be able to reverse that and say what angles have a cosine of root 3 over 2? 11 pi 6 and pi 6. Okay, we did a lot of this in the second unit. You guys did a good job with it. Just want to make sure you still remember how to do this. Okay, if not, you can also look back at some of the resources we have from Unit 2. Cool. Okay, so we were actually solving linear trig equations there. Okay, the thing that was really nice about those is we didn't actually have to do any algebra. Like we didn't have to do anything before we just thought about what the angle was. In general, when we look at trig equations, we're going to have to do this first. We have to follow your order of operations to isolate the trig expression. So usually we're going to actually have to do some algebra. Add 2 to both sides, divide both sides by 3, subtract 5 from both sides, multiply both sides by 2. Do some algebra in order to get the trig expression by itself. Isolate the trig expression. Once you have the trig expression by itself, once you have cosine of theta equals a number, then you guys can do this. Then you're just going to find the angles that satisfy the ratio in the given range. We specify in the given range. Remember back to Unit 2. Because if I say sine of my angle equals 1/2, tell me the angle. Well, it could be pi 6. It could be 5 pi 6. Oops, sorry. It could be 13 pi 6. It could be 17 pi 6. There's infinitely many angles that have a sine of 1/2. And so we're generally going to restrict the range so that you don't have to get infinitely many angles. Instead, we're going to say, like, tell me all the angles between 0 and basically, these all involve just doing 1 or 2 steps of algebra, maybe a few more at the beginning, to get the trig expression by itself, and then tell me the angles. Okay, we'll do a couple of these together. I'll let you guys try a few, and then for this one, the trig expression is sine of theta. Is it by itself? No, it's being multiplied by 2. How do I get rid of the times 2? Divide both sides by 2. Now the trig expression is by itself. Okay. We still have to solve that equation. I'm going to come back and do that in a second. What I want to show you is this problem now looks exactly like these problems, which you guys can do. Okay. We're just doing a couple steps of algebra first. Secant of theta minus 2 equals 0. Add 2 to both sides. I'm trying to figure out where secant equals 2. We still have to go back and do that, but I just wanted to show you the algebra part first. 2 cosine squared of theta minus 1 equals 0. Add 1 to both sides. Algebra, algebra, algebra. Sorry. Divide both sides by 2. Just doing normal algebra here. Last step, square root both sides. All right, I got to get rid of that squared. I want the trig expression by itself. I'm going to try to figure out where cosine of theta equals the square root of 1/2. What's square root of 1/2? Well, square root of 1 over square root of 2. Square root of 1 is 1. It's 1 over the square root of 2, which if I rationalize is square root of 2 over 2. Now, don't forget, when you square root both sides and you're solving an equation, you have to add a plus or minus. Okay, so we're really trying to figure out, when does cosine equal positive root 2 over 2 or negative root 2 over 2? Okay. Let's go back and find the angles for these first 3, and then I'll let you guys try the bottom 2. So, okay, now I'm back here. When does sine of theta equal 1/2? Well, when theta equals pi 6 and 5 pi 6. The easier you can answer that question, the more efficiently you'll be able to solve these equations. And we do expect to be able to answer those. 20 seconds. That's why we did all those unit circle practice and those evaluating trig functions quiz. Okay. Secant of theta equals 2. Well, that means that my cosine of theta equals 1/2. When does cosine equal 1/2? Pi thirds and 5 pi thirds. When does cosine equal positive or negative root 2 over 2? Well, it equals positive root 2 over 2 at pi fourths and 7 pi fourths. And it equals negative root 2 over 2 at 3 pi fourths and 5 pi fourths. Notice I actually had 4 solutions to that equation. There's 4 angles to make that equation work. This equation was actually not a linear trig equation. It's a quadratic trig equation. It had a trig function squared in it. But you can still just use algebra to get it by itself. We're going to talk a lot more about those two, especially once it gets trickier. All right, last thing I want you to do, give number 10 and 11 a try on your own, please. Pause, give them a try, and then we'll go. Okay, just a few comments here. So this was, again, a quadratic trig equation. Quadratic. A square trig, because it had tans in it, not just like x's. And we solved it using the algebraic strategy of taking the square root of both sides. If you really want to get technical here, we got the tan squared by itself by adding 1 and divided by 3. We got the tan by itself. We got rid of the square by square rooting both sides. When we did that, we remembered the plus or minus, and then we rationalized it so that it looked familiar, like something that we know on the unit circle. Because of the plus or minus, I ended up getting 4 solutions. There's 4 times where tangent equals plus or minus root 3 over 3, because there's 2 times where it equals root 3 over 3, and 2 times where it equals negative root 3 over 3. Yeah. Paying attention to the number of solutions and making sure you don't miss any is going to be something that's important this unit. For number 11 here, I have a feeling that you guys added the 2 over, and that you guys squared both sides. I know some of you guys did this. You saw a square root and you said, oh, I have to square both sides. No, 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 no. You don't need to get rid of the square root. You need to get rid of the square root of 3. Square root of 3 here is a number. It's like 1.7. Pretend like it's 1.7. You wouldn't square both sides because you have a 1.7. If you had a trig thing under a square root, you might square both sides. If you had a variable under a square root, if you just have a square root of 3, it's just a number. Treat it like a number. You add the 2, you divide by the number. And right here, one other comment, I bet a lot of you guys try to rationalize the denominator here. It's actually inefficient to do that because the first step to figuring out when cosecant equals theta is to flip it. You don't really need to rationalize it because you're going to flip it anyway. The sine of theta equals root 3 over 2 at pi thirds and 2 pi thirds. That concludes this video. Thanks for watching, guys.